Hello students, today we are going to start the first topic, some basic concepts of chemistry. So under this, as I mentioned earlier, we shall be beginning with the laws of chemical combination. Under this, the first law is law of conservation of mass. As the name states rather, when any chemical reaction or physical changes occur, the mass of the reactant and the product will always be same. So you can check the definition, it's written in all changes, physical as well as chemical, the total mass of the reactants and products is the same. You have an alternative definition also, matter can neither be created nor destroyed. That means total mass of the reactant has to be conserved when the product is formed. So to understand this, we can take an example. I have given you a numerical here. When 4.2 gram of sodium bicarbonate is added to a solution of acetic acid weighing 10.0 gram, it is observed that 2.2 gram of carbon dioxide is released into the atmosphere. The residue left was 12.0 gram. Show that law of conservation of mass holds good. So as the question states here, you can understand the reactants are sodium bicarbonate. The reactants are sodium bicarbonate and acetic acid. So it's always advisable to write the chemical equation. So you have tried to write the chemical equation here, and the product formed from your previous knowledge, you know that when acid and base or carbonates they react, they form salt, water and carbon dioxide. So here in the question they have given you the mass of carbon dioxide, and by residue out here we mean the salt and water. So just below the symbols of the formula of the compounds, we have written down the mass as given in the question. So sodium bicarbonate mass is given 4.2 grams, so we have written here. Mass of acetic acid given 10.0 gram, we have written here. The mass of the residue, which means the salt and water, is 12.0 gram, and mass of carbon dioxide is also given in the question, that is 2.2 grams. So when we add up the mass of reactant, we find 4.2 plus 10, that is 14.2 grams. And mass of the products also we add, we find that 12.0 plus 2.2 gives you 14.2 grams. So you can see in both the cases, the reactant and the product, the masses are same. So this experimental evidence proves the validity of the law. So the law of conservation of mass holds good. Next law is law of constant proportion. It means that if a chemical compound forms between two or more elements, then doesn't matter from where you collect the compound, it will always have the same elements, and not only the same elements, the masses of the elements will always be having fixed ratio. So the statement goes like this: a chemical compound always consists of same elements combined together, underline this, same elements combined together in the same fixed ratio by mass, whatever be its source. So to understand this, we take the example. If water is collected from various sources, say we collect from lake, rain, pond, wherever, it will always contain hydrogen and oxygen only. It will not have any other element. And the ratio of mass of hydrogen and oxygen will always have the same fixed ratio by mass. That you have to keep in mind, by mass. So I have taken the example of water, which contains an hydrogen and oxygen. Since the formula of water is H2O, so 2 hydrogens mass will be 2, 1 oxygen mass will be 16. So the ratio of oxygen and hydrogen and oxygen is coming to be 1:8. So doesn't matter wherever from you collect water, it will always have the mass of hydrogen and oxygen ratio 1:8. Let's take another example of carbon dioxide. You can collect carbon dioxide from various sources, so from say by burning carbon, by burning any fuel, from respiration, from any soft drink, alright. So the mass of carbon is 12 and that of oxygen is 2:16. There are 2 oxygens, we have to multiply by 2. So the ratio of carbon and oxygen will be always 3:8 irrespective of its source. So that is what we understand by this law. Now to support this law, we have one numerical here. It states 2.750 gram of cupric oxide contains 2.196 gram of copper. In another experiment, 2.358 gram of copper forms 2.952 gram of copper oxide. Show that the results illustrate the law of constant proportion. Now, how do we work out this problem? If you read this question, you can understand there are two situations. So, we have mentioned here observation 1 and observation 2. Mass of cupric oxide is given. But what does cupric oxide contain? Cupric oxide contains copper and oxygen. So, mass of copper we know as given in the question, but mass of oxygen is not known. To understand the mass of oxygen, we have to subtract the mass of copper from mass of copper oxide. So here you can see we have written mass of copper in case 1, which is 2.196 gram as given in the question. In the second case, it is given 2.358 as written here. Now to find out the mass of oxygen, we have subtracted the mass of copper from mass of copper oxide. So we know the mass of oxygen. As you can see, the values are not same. But when we take the ratio, you can see here the values coming to be 3.96 in both the cases. So which proves the validity of the law. Then we move to the third law, law of multiple proportions. So if two elements combine to form two or more compounds, remember two elements, same element, they have to form at least two compounds. That is the criteria. Then the weights of one element which combine with the fixed weight of the other bear a simple ratio. Let's understand this law. You know that hydrogen and oxygen can form two compounds. One is water, another is hydrogen peroxide. So the ratio of hydrogen and oxygen in water is 1:8 and that of hydrogen peroxide is 1:16. So what you notice here, in both the cases the mass of hydrogen is same. So if we compare the mass of oxygen now, we find that the ratio is coming to be 8:16, which is a simple whole number ratio because it will come to 1:2. Okay. Let's take another example. Say we know carbon can form carbon monoxide and carbon dioxide. So the ratio of mass of carbon and oxygen in carbon monoxide is 12:16 and that of carbon dioxide is 12:2:16. I am not multiplying to write 32. The calculation will become easier if I leave it like this. Now since the mass of carbon is same in both the cases, what we can do is we can compare the masses of oxygen. And you notice here it is coming to be 1:2, which is a simple whole number ratio. So this way we can test the validity of the law with various compounds. Please try with ferrous oxide and ferric oxide. Mass of ferrous oxide is 56. Please try it out. There is one example in your textbook, example 1.21. I think so. Please check it out. It's a question related to nitrogen and oxygen. Please solve this question and one or two of you please send me the answer also. Thank you.